In this lesson, we're going to discuss decisional programming in MATLAB. The learning objectives are first to understand the input syntax and logical outputs of relational operators and also logical operators. And then second, to use if-else and if-else-if-else decisional structures within a script to control the decision to make calculations. And third, to develop pseudocode for basic decisional programming and then incorporate this into the program contents. So today we're entering into a new section that's on basic logic in computer programs, and MATLAB in particular. So a MATLAB program is nothing more than just a sequence of computer commands that we call sequential programming, and they're organized to accomplish a particular purpose. So far we've worked with simple computer programs that have a command that are executed. So far we've worked with simple programs which the commands are executed in the order that they're typed, so in series from top to bottom. So if you open up your starter code for triangle side links, we'll be working with this today, and we can see that here we have the first thing that we're going to define the coordinates of each point on the shape, which hopefully is a triangle, and then we'll next calculate the side lengths of the triangle, calling the line length function that we developed in our custom functions lesson. And then at the end, we'll display the side lengths within the command window, just using the disp command, and also now incorporating the num to string command within this. In the past, we've called this sequence of comments, this define, calculate, and then display. We've called this pseudocode, and we use these steps as comments within the function. But one thing we have to realize is that many, if not most situations where you'll be writing MATLAB scripts will have situations in which the commands aren't necessarily executed in the order that they're typed. So for example, we'll have some situations that require decisional logic that we'll talk about today. So for example, if we've got a computer program that is calculating the cost of mailing a package for the post office, it may use different mathematical expressions depending on its weight, its size, content, or maybe even the types of service. And another way that we'll talk about next time is that when we need to have commands that are executed over and over, and to do this only while a situation is true. An example of this is looking for minimizing the error when homing in on like the square root of a number or optimizing the coefficients of an equation. And so either one of these situations we consider decisional programming. At the heart of decisional programming are the relational operators. And I can say that early in elementary school, even in kindergarten, my children were getting math problems about which bowl is bigger than the other, or which bowl can hold more, which are the same sizes. And so that's what we have here. With these relational operators, we're just systematizing these basic concepts where we have less than, greater than, less than or equal to, and not equal to. And in the comparison of these operators, if the comparison statement is true, then it results in a logical 1. Otherwise, it results in a logical 0. So it gives us a binary structure in which to work with. One quick note is to look at the equal to comparison statement. This has a double equal sign, and this is to distinguish it from the assignment operator, which only has a single equal sign. Let's go to our command window and try out some of these commands. So first we can type in 5 is greater than 8, and we expect to get here is going to be a logical array. It's a 1-by-1 array, and it gives us a logical 0. Now we see that in the workspace our logical array has a different symbol compared to our numerical array. Our numerical array has the an array squares, and our logical array gives us a check mark. So that's a logical 0. If we flip this and we say that 5 is less than 8, we should get a logical array with an answer 1. We can assign any of these arrays to a variable. So we now have variable A that has a logical 1. And then we'll show in a moment how these are useful when indexing other arrays. Let's apply these logical operators, these relational operators, to matrices now. So we have the matrix B, which has the elements 15, 6, 9, 4, 11, 6, and 14. Then the matrix C, which has the elements 8, 20, 9, 2, 19, 7, and 10. Let's determine which elements in matrix C are greater than the elements that are in B. So we can create a variable that says when C is greater than B, and we'll simply type C is greater than B, and from this we get a logical array which gives us a series of zeros and ones, binary. So in this case, C is not greater than B. In the second column we see that C is greater than B, and this is going to correspond with 20 is greater than 6, 8 is not greater than 15. Let's flip this around and let's look for when B is greater than C. And we should get just the inverse of this logical array that we got prior to this solution. Now, a really cool part about these logical arrays is that they can be used to address any other array. So for example, if we wanted to isolate the values of matrix C that are greater than B, then we would just simply type in C, and on the inside we want C when C is greater than B. So we'll put in this logical array, and it's going to give us 20, 19, and 7. And so when we compare these positions, 20, 19, and 7 are each of the elements in which this comparison was greater. And let's say we want to take the mean of those comparisons. We can type in the mean, and we get 15.333, or let's say we want the standard deviation, 7.2342 of these three numbers. The next layer within decisional programming are the logical operators. And logical operators, just like rational operators, can compare any combination of scalars and arrays, but what they're doing is they're taking the rational operators and they're making comparisons based on those. And the three primary logical operators that we'll work with is the AND, in which we're saying these two logical inputs, if they're both true, the result is true, otherwise it's false. The OR, which if either one or both are true, the result is true, otherwise it's false. Or the NOT operator, which gives just the opposite, true if it's false and false if it's true. Let's return to the command window and try out these logical operators. If we say we've got something like 3 times 4 is less than 5, and that will give us a logical operator, and we know that that's not true, and then we want to test that with 5 is less than 6. So in this logical operator, if both of these are true, it would give us a 1, and so we can test this again by making them both true, which 12 is greater than 5 is true, and 5 is less than 6. Let's take a look at the logical operators when dealing with the two matrices that we had before, which is when B is greater than C and when C is greater than B. And so if we combine these into an AND in which we're looking for them both to be true, then we see that our logical array is 0. So at no point are these both true. And if we put this into an OR, in which just one of them is true, then we see that we get a 1, 1, 0, and 1, 1, 1, 1. And so the 0 is going to indicate, in this case, in this comparison, that they were equal to each other at that particular element. And then applying the NOT operator, this is the tilde. And so if we do when not, when C is greater than B, then that's going to give us just the opposite of the logical indices that are in that particular array. Now, as an exercise in logic and indexing arrays, this makes it a really interesting puzzles to figure out and just an interesting situation. But really where these statements begin to make sense, or these tools are helpful, is when we incorporate them into conditional statements. And so that's where we're able to use the if-else decisional structures. So we'll have a conditional expression that's stated, such as if the conditional expression here, and if this is true, then we see that a group or a series of commands is executed, or, and this is where our else command comes in, a different set or series of commands is executed. And what we see here is a flow chart. We have if our statement, if it's true, we get these commands. If our statement is false, we'll get these commands, and then the program continues. And in the MATLAB syntax, we use this as an if, else, and then don't forget to put in a final end statement, which completes our decisional structure. Let's take a look at the triangle side length script and then enhance this with a decisional structure. So the first thing that we'll do is we're going to extract the comments here and then create pseudocode about the decision that we want to make, that we want to place into this code. And the decision is to determine whether, when given these points, whether there are 3 points, therefore it's a triangle, or if there are a different number of points, it's not a triangle. So open up a Word document, and then in there transfer the comments. So the first comment was, or the first step rather, in the pseudocode is to define coordinates of each point on the shape in an array with x coordinates and y coordinates. The second was to calculate the side lengths of the triangle and then display the side lengths in the command window. And so in these larger sections of code, we want to calculate the side lengths if the shape is a triangle. And then it's within this section that we want to put our decisional structure. So first we want to test and see if the shape has 3 points, and that will tell us if it's a triangle. And then the next part is our else statement. So else the shape is not a triangle. And then after we've defined this, or determined that if the shape does have 3 points, then we can calculate the side lengths. And then right after calculating the side lengths, we can display the side lengths. And then dealing with our else statement, if the shape is not a triangle, we need to tell the user that this is not a triangle. And then after this, we can remove this larger section, which was displaying the side lengths, since we've taken this up and already done this in the if statement. So let's take this and incorporate it into our code. So the first thing we need to do is add the comment, calculate the side lengths if the shape is a triangle. And the current commands and calculations should only occur if the shape has 3 points. So we'll place the comment underneath our larger section. We can remove this. Calculate the side lengths, or what these 3 commands are here in series, and then displaying the side lengths is only going to occur when this logic is satisfied. And so let's place in our decisional structure to test whether the shape has the 3 points. And so this is if, and to do this we have an array of these points. And so we want to make sure that the number of rows is equal to 3. So we can do size points, and then we want to know the number of rows. So points, comma 1, and we want to make sure that this is equal to 3. So this command is saying if the size of our array, only the length of the rows, or the number of rows, is equal to 3, then this is testing if the shape has 3 points. If that's true, then make these calculations for side lengths, and then output that to the user. So we need to always incorporate an end at the end of our decisional structure, but we also want an else statement here that's going to tell us, or we're going to say that if there's not 3 points, then the shape is not a triangle. Let's go back to our pseudocode and put this in, else the shape is not a triangle. And so we'll do this by saying else, and that's any other condition. And then now we need to put in a display telling that the shape is not a triangle. And we'll do that by displaying DISP, this is not a triangle dummy. And then to clean it up, let's put in a couple more DISPs just to put some lines in between our statements when we call and when we're making our display. And so one of the things that you'll see here is that our formatting is a little bit funny. Everything is lined up against the side. And so a quick tip here is you can use Command A or Control A for selecting all of your code, and then Command or Control I is going to then allow the proper indentation and formatting within your code. And so now if we run this script, we know that we only have 3 points within this matrix, and so we should get side 1, side 2, and then side 3. Now let's change this. Let's put in a 0, 0 as a 4th point, and if we've done this correctly, it should output a message to us that says this is not a triangle. Let's take a look at one last decisional structure, also in your cheat sheet, in which we have an if, else if, and else structure. And so we can keep the same if conditional expression, but then we have an else if, which is going to be another specific conditional expression that would come before the else, which takes care of all the other situations. So back to our code. Let's place in an else if, and let's use our else if to test whether there are 4 points, and if that's the case, the shape is a quadrilateral. So let's copy this where we're testing to see if there are 4 points. And back to our pseudocode, we're going to put in an else if the shape has 4 points. And in that condition, we want to tell the user that it's not just not a triangle, but that it is a quadrilateral. So we'll take this pseudocode, and in our else if the shape has 4 points, tell the user that it is a quadrilateral. We can do that. This is not a triangle dummy, it is a quadrilateral. And so if we have programmed this correctly, then we would run it, and we know that it has 4 points because we've given it a 4th row with the 0, 0, x and y coordinates. Then we do get our message that says this is not a triangle dummy, it is a quadrilateral. And so in summary, by beginning our basic logic section here and tackling decisional programming, you now have the tools to use these relational operators within the context of larger logical operators in the context of decisional structures. And you will be using this often within several different aspects of your programming. In addition to that, I want you to be thinking about pseudocode and how to structure your logic before you do any programming on this. And I predict that that's going to speed up your programming process with that work put in the beginning, and in addition, it's going to allow you to create or cause fewer errors and debugging problems.